Right, hello, welcome everyone to my next stream where I'm making my dream game using a bunch of AI tools to help me because I've never made it before, and it helps me progress much faster than if I wouldn't have those tools. Where are we today? So in the last episode I had hoped to finish the game loop by doing the wires, but there was quite a bit of tricky stuff, so I hope that we can finally solve all of the issues today, where we can wire up the power generator here on the right side that is now generating power when I dump resources into that, and like divert that power using wires to the charger, which I'm using to power up the robot, which I'm using to clean the dust, which I'm using to power the fuel. So that's kind of the game loop what I'm going for right now, before we extend the game to a much bigger world and much more, many more devices and machines that will make the game more fun. Again, I'll just click play just to kind of check if everything is working. We did have a bug last time where my robot was no longer charging, so we can switch between devices that we control. However, currently only the robot is one that you can actually move around. So as you can see, I'm running over the dust particles, picking them up. I can dump them by just moving here, and then it gets basically consumed by this generator, which keeps the power at a maximum level. If this is going to run out, you will see that the power level is going to drop. Okay, I just kind of lost the game because my Roomba is now out of power and I cannot move it anymore. So let me just quickly restart and show you then how I can recharge. But as I said last time, there was an issue. I had been playing around with layers, so maybe I think that's one of the main reasons why it works again. Yeah, I think I've did some basic messing around with the layers, and apparently I fixed it. So that's good. As you also can see, the wire is being connected automatically once the game starts, so I'm telling the wire is connected to these things, and it will set its ends positions to the connector modules of the devices that are connected to the wire. So that's cool. The only thing that is that, like, as you can see right now, the power is starting to drain here. Oh, but the wire is not on, so I had like a little debugging tool where the wire is not on, so currently there's actually no connection. So I think if I connect this, you will see that the power is now draining much faster here, and in theory it is charging this, but it is charging it at a slower rate than what it's consuming, so that's a bit of a downside. So actually what I could do is I could set the idle power of all my devices to 0, that they only consume power when they're actually doing something. And the reason why I did that in the beginning is, well, I mean, at some point in the game I do want idling to still consume some power, but it was mostly for debugging because nothing was consuming power already, so I had to have some proxy for, like, okay, what happens if power is being consumed. But right now I have a lot of stuff that is consuming power and transferring power, so maybe it's a good point to actually set those things to 0. And I think I need to do that in the device. No, it's each module, I guess. That's a bit annoying. Install on device. Don't they all have like a certain rate? Oh, it's not serialized, I assume. Right, so I should copy paste this and put all of them to 0. There you go. Replace. So all of the power draw should now be at 0, 0, 0. This one was 0.1. Let's also put it to 0. Let me check for this. Are they all 0-ish? I still have one here that's not 0. There you go. 0. Can I do that? Because no, I can't, because this is a weird part. Which is this? It's the network module. Oh, power module, resource module. Where are you? Idle. Wait, you don't have that? Oh. must have copied it from the wrong module. 0. Right, this is all now drawing 0 power, and theoretically maybe I could even... No, let's just test it, because at least it should now increase my power at some rate if... Let's see. Right, so that's working. There's power there, so actually all I need to do is activate the wire. No, why is this still... No. That's not... That does not make sense. It should not be going down at all. Because nothing is supposed to be drawing power right now. If and if... Only if... Is it not serializable? I should serialize that though, so I can see it. Okay, so I should replace public override load idle by serialized fields. At least I can see, because it's still kind of a mess sometimes. Where... What are you talking about? Unused. I cannot do that. Does it do it everywhere? Oh, that works though. Yes, let's go to the device module then, maybe, because there, I guess I could. Here I should be able to say serialize, right? So I need to... I don't really want to see these things in the inspector. Oh, that's a bug. Cannot be private, but I'm not asking you to set it private. I'm asking you to make a serialized field out of it. Honestly though, not valid for this item. Why? Let's see, fix using Copilot. Alright, we're gonna have to do it differently then. Okay, there's something wrong here. We're just gonna have to log it in every device. Console.log. No, this is JavaScript. It's debug. .log. Idle power draw. And I also want current. Yes, these are the two things that I want to be printed. I still have a lot of other stuff being printed right now, so let's just quickly get rid of that. Although, no, it's fine, I'll just find it in between. Because it should all be 0. Current power draw 10. I can search for idle, right? Yes. So it's all set to 0. The question is then, why is some of them set at 10? Okay, that's interesting. So you, can I know which one it is? Do I know from which object this is being? Okay, current power draw on, yes. Module name? No, also on device name. On device, there you go. I think name is more than enough, right? It should work. Correct. The charger for some reason is spending a lot of power. Even though the idle is set to 0. Nothing is charging. Let's pause. Zero, yeah. 10 on the charger, but why? So let's go to the charger, which is basically, must be from the power module, no? Let's just look for the number 10. Isn't that like... No? Let's close all of them. Update total power charge. Up. Debug this. Power drawing modules. Oh, okay, that's true. So let's check if I'm still in pause, which I am, but it will probably stop because I changed the code. Yeah, that won't work. I can check quickly what behavior is missing. All right, let's press unplay. Let's press play and then pause and then check which devices are drawing power. Power pull 10. There's pull, but that's on the wire, right? So that doesn't have anything to do with, at least it shouldn't. Yeah, so let's go to the charger, look at its power module and check power drawing. So it's the computer, the network, the power itself, and the connection. But all of these should still be at 0, and that's what is a bit confusing. Module current power draw. Let's check this. Is it? Maybe it has to do with the cable being connected. Can I disable the wire? I should be able to disable the wire, right? Like this. Let's just disable the wire just to check if that's part of it or not. Why is the charger total power draw? Can I put it? Is that like just because? That's so strange. No, it's calculated. Right, let's press play again. Are there any devices that are being shown in the charging? Is it faking that it's charging? No, charging is empty. Okay, so can I look at each of these devices? Does it show the current power draw? No. Well, current power. Oh, here you go. The connector on the charger is drawing 10. Did I fail to... It's set to 0 at... I knew it was... That's why I looked for the word debug. I didn't see it. Reset. Let's remove this. That's exactly what I was thinking. I was adding it artificially. So what were we testing again? Oh, I should actually activate the wire again. Sorry. So let's see. Activate the wire. Right. Let's not turn it on yet. Let's just activate it. Put it in the scene. And then let's charge. So now no charge is being, only if I'm charging there should be some loss. There you go. Okay, and now if I turn on the wire, if everything is done well, yes, look, it's charging. Amazing. The thing is, you can see that it didn't actually take that much energy, right? So it gave this thing more energy than it was drawing from the power line. So that's a bit counterintuitive. Not counterintuitive, it's plain wrong, sorry. But at least it's working. Because as far as I know, this is being charged, but the power is not being drawn properly. I don't know why. Alright, but at least we're there, so that's good. This was... I don't think we need this anymore. Let's check. So it's time to have another look at the wire. For each power pusher, pull divided by 1. We should be... What's the power pull though? Where do I calculate this? Right. So that's the thing. The current power draw of the connector is not being updated, I think. Not anywhere. But that only needs to be updated when you start charging. So let's go to the power module somewhere where it's when I'm... How is the power doing that? Line is adding power to the charger just automatically, I guess. Power conduit. Power puller. I'm giving you some power. Yeah, I'm just charging 10. So this I'm just doing this like randomly, right? So power pull needs to be updated at that point. But that's the thing, like the wire doesn't really decide how much the puller is pulling. So we need to add private float power pull. And the power pull on a connector is 0 by default, unless something within this thing says, oh, connector, pull something from the wire. And that, for example, have so set power pull. Yes. Although again, it would be easier if we can like add different types of power pulls. But again, so the I think the connector should be a power drawer, which it is, right? Oh yeah. So it's not power pull. We should just set the current, which is already existing. Connector. So this should have an okay. So this should have a field for the power module. So device power module, and we can do that on initialize. We can say yes, that's true. Kind of. Connection type is power, then power module needs to be filled. And we should add this connector. So we go to power module dot add power charging this. Why don't you like this? Yes, and that's the issue, right? That I cannot make the connector a charger, but that's actually what needs to happen though. So the connector is now going to charge it, the thing. This is not allowed. We're going to change this. Let's see if I could just go like this. Let's just change a few things. We need to change this into also device modules. Now, there's going to be a time when that's fine. Wouldn't this work already? Or is there still a bug here somewhere? Red flag. Where is the squiggly line? Here somewhere? It's showing red here, but I don't know why. I don't see it. Let's open it up. Oh, okay, it wasn't open up. There you go. There you go. And then, okay, when it does that, let me check what happens though. So update total power charge. We're a module current power draw, which is then a negative. Yeah, so the power draw of this module needs to be negative or positive of the connector at that point. And this dot add functional power draw charging from the grid, and let's put that to like NF, right? So the connector can at most charge the thing, so this should be charging now. This should only happen if there's actually enough power in the wire, right? Otherwise it's not possible. So let's open up the wire itself. Like, how do we... Yes, the power push. Power pulse, that's defined by adding this, it will start to pull this much. So in the end, this wire, when this is set to a certain pull, then this should be also set to draw as much power as being drawn from this connector that's pushing it there. This one should be pulling it from that. That's kind of what needs to happen. So the wire, maybe it does need to happen in the wire, because I can access it. No, I do need to add it. That just needs to happen. You can charge from me if I if my power draw is a certain value, because if it's not a certain value, it will just be 0. So that's kind of correct. So by default, there's no functional power draw. Good. This is already set up that it's drawing power. So I had to set up that this could charge this in addition to drawing power from it as a regular device module. Now the same, this is already set up that it will draw as long as I set this. So basically now everything needs to happen from this side here. Right, if it's turned on, yes. If it's not turned on, if there's a 0, if the wire is turned on, the power pushes, yeah, but that's actually what already happens, right? But what the question is, what is the size of power pull? I think I need to add some things here. So float, max, power, pull, and float, current, power, pull. We can say at most you can, this connector can pull 10 whatever from the grid. So we kind of need to check. To be fair though, I'm kind of thinking right now, does it actually make sense that this thing has a charge? Because it's just generating power continuously. Does it actually have a battery inside? Maybe it shouldn't have a battery inside, and that's the whole point. So if we go to the generator, we do like here charge. Or maybe we shouldn't do that actually. Maybe we should just set a certain amount of power that is being generated. Whether or not it's being used, that doesn't really matter. So I'm not really pulling it from a certain buffer. If it's not used, it's wasted. I think that's also how it works, for example, in Oxygen Not Included. Because if you have like the generator, if it's running, if you don't use it, it's lost. It doesn't get stored. And that also kind of brings into question, like, that's why you would place a battery next to this as another device. And that actually makes more sense. So rather than adding charge here to this thing, I would just say power output. So let's go here, serialize fields. Now this is a lot of low power output. Well, no, obviously 0. Come on. And then here we go, this dot power output is sure energy generated. we're burning it, as long as we're burning it and take 1 second, in that 1 second we have a certain amount of power. Meaning also that this power module on the burner doesn't actually make that much sense. There's no power. Which also means, so if we okay, let's disable this. I don't want it. But what we could do, okay, let's enable it again, but let's remove, or let's at least disable this script. And in the generator script, this should become my generator. That's what I'm saying. And then just this gauge here just shows you the current kilowatts that is being generated. It's quite static. It's like, it's just, if you burn dust, it will always be constant. It will either be 0 or some value. But if you would be burning like wood, it would be a little bit higher because you have more energy from one burn cycle. And that's about it. And it just has a constant output. As long as it's burning, it has a constant certain output. And that's it. And that's all the wire needs to know, like how much kilowatts of power is available in this wire. And I don't have to care about all these intricate things because, again, it doesn't make sense to have a battery inside this burn. All it needs to do is generate a certain amount of power. Yeah, so that's kind of how I maybe prefer to do it. That being said, let's disable this thing. It's just that I want to move these charge fill bars into power fill bars. And I do need to kind of have the code set out for that, which is available on the power variant itself. But let's do that for later on. This shouldn't break anything as far as I remember, except for the fact that, oh yeah, because now like the network and the computer, they don't have any power to draw from, which means they will be unpowered. Everything will be unpowered. Question is, do I even need a network or a computer on this machine? Well, okay, so let's enable it, but let's say this is an infinite amount of, sorry, that this is has for now, just like our vent, some kind of an infinite power source. Has infinite power, just to power the peripheral instruments on the thing. But I will disable this. Well, no, we don't have to disable it. I don't actually have to get rid of this power thing right now, but I should keep in mind that this no longer relates to the power being generated. The generator itself now, instead of pushing charge to the power module, it just says I'm generating this amount of power output. I'm gonna make a function get float get power output. Go. And then the connectors, actually max is not really relevant right now. I just say current power push private, right? Oh no, this is not for the connector. Connector. Yeah, we already have this, so that's already being dealt with. But connectors do have they just have a general because it doesn't have to be power necessarily. But I don't know if that's a good idea though. And we don't actually need a reference to this, but to the generator. There you go. Device. Module generator, and then our current, what was that? Oh, the music stuff. Current pull is yes. Push, sorry. That won't work, so you need to use the get. There you go. So the push on this connector is whatever the power output is on the generator on that device. That's fine. The pull on this connector is not relevant. Well, okay, sorry. If it is connect type power and and now we check if the direction, connector direction equals input, then it's about pull. Otherwise, it's about push. Let's connect where yes. We can indeed do this outside. Right, so what we're doing, if the connector is of type power, it's a power connection, then we need to check for a generator module, and maybe in the future even a power module, but now we're going to keep it simple. Just check for a generator module, and if your connection type is input, then I need to update my pull I would really rather call it output. Current input. But that is actually not relevant, sorry. It's only our output. Yes. Or just in general, the output and the input. Output is the power output, and then the input is not really relevant. What is the input on a connector? It's whatever that's true though, like this is only relevant in this case, because in this case basically there's only two things that will be connected to this. It's either a generator which generates power. On the other hand, if on the other side there will be a power source that needs to be charged. So if we blah blah blah. So here we need to check for the power module. There we go. And the input is the power module's like current total current power draw or something, right? Not charge, So the power module has some what is it's whatever a power module wants to charge at, and it will try to do that of the time, but if there's no connection, it will just not happen, right? So from the power module side, it just always wants to check if there's a connector, if there's a power connection, and if there is, it will add that power connector as one of its chargers. If it's an input power connector, it will add it as one of its chargers. Yes, that's correct. Here. Check for input connectors. Right, and this function, actually private, check for input connectors for each void. Do I have a list of connectors? No, you just have to find installed on device dot find. Does that not work? Oh, that's like find module or something. Don't I use this thing everywhere? Find. I think I use this like everywhere on the device script. Get installed module by type. This is assuming there is only one ever. Get install module by type connector. Right. Just find a connector. Need to make a field for that. Connector. What? No, device module. Input. Sorry, we need to call it power input connector. And then okay, so now if connector type and is power. Yes, that's what I want. Does that not exist? Get connection type. That's strange. That's a bit weird. Get connector type. Yeah, sorry. Well, not sorry. I mean, it's just whatever. So we're gonna get a connector, but it's only gonna return one. And if there's multiple connectors, it will fail. You know what? It would be easier to just say, I'm not gonna look for it, I'm just gonna assign it. Because it's here, serialized. I'm just gonna say this is your input connector and that's it. So you don't even have to check for it. And at the start or up an initialization of this module, you just need to add it. For each module on installed, but it's already being added as a. Oh no, it's for charging. Power drawing device. And then I need to do this as well, namely our charging device modules dot add not this but the power input connector. There we go. But let's first check if it exists. It's not equals 0, no, then add that. I think it's this simple, even though the code is not simple anymore. So if there is a power input connector, add it to one of your charging devices and it will start charging if it's possible. Because what happens if we go to update charging status, charge from connector. Let's close. How does this thing charge itself? That's not starting to charge is also adding, but this will add it continuously. The difference is that it will I'm looking it's the current power draw that's being used. All right, so the connector itself, if you are an input, okay, you see, that's the thing. The input of a connector doesn't come from the power module. That's the thing. It comes from the wire. So you need to check your conduit. Yes, this is what I was having issues with. And now you need to get on the conduit. There's like a total push or something. Power push. I just want to get it to work and then fix all of the stuff. But I think we're getting, because we're so close to like having everything in place, that it's also normal that the code is getting a bit messy. Maybe like a refactoring halfway would have been good, especially in terms of power, because the rest was fairly simple. The power is really, it's very tricky. So this wire is now checking has a certain amount of power, which is called power push available, right? Do I need to care about this? I think this is actually quite useless. It's more like a certain connector is going to take away a certain amount of the total available amount. Let's call this, let's change the name. Available power, used power. Yeah, I think just changing the terminology is gonna, there you go. So the available power is the total amount of power push. That makes sense. And how much I'm using depends on the connector here. Go back to the wire. So there's a certain amount available, and that's determined by how many generators are connected through its connector, because it's looking at connectors, right? Power puller. Is it always a connector? Yes. Gonna get rid of this. It's not current power draw though. It's the output. Public float, get output, yes. And when I'm going over like how much is there, it should be get output. That's the amount of push that there is. Let's call it available power on this wire. Let's get rid of this. This one is called update available power. I really like changing variables names can sometimes really help you, because it helps you think better about if you use bad variable names, it will make the thinking process difficult. Right, so update the available power, which is by going through all of my connectors or power pushers which are inputs. So these ones. If the connector is an input, then you are a puller. Yes, if the connector is an output, then you are a pusher. That's true. Let's go quickly check if that's correctly assigned here. Why is there a hand? There's like a bug here with my... Let's not care about that right now. There's something wrong with my mouse. It's constantly in the same mode. Used power. Good. Reused power. Let's just see if... So the idle power draw... Okay, wait, I do need to get rid of a lot of debugs here first, because otherwise it will be impossible to see. Okay, this one, get rid of it. Get rid of it. Charge, don't trigger it, get rid of it. We fixed... Oh, did I do something? No, it's fine. It's a warning. You can get rid of that. Right now I want to see what the available power is in the wire. also want to see it in the generator. So you generator, I also want you to output your power output. Yes, power output of the generator. And then how much power is available in the wire. In wire, let's just see if that already works, because that would be nice. What? Yeah, that's strange. It doesn't, it's not updated. That's interesting. Let's close it down. Let's go back and forth and update the code. So at this point, the wire works in the sense that it does take power and it inputs power, but their numbers are just wrong. It's not related to what it's actually being used. So that's kind of an issue right now. Alright, you have a lot of issues. Power in wire 0. Power in wire 0. Why is the generator not showing anything? Yeah, that's true. I did say I was gonna, yeah, so if I go to the charger, module power, I was gonna, power input connector, there you go. So this one needs to be added here. Oh, I should stop. Power input connector, there you go. And the same probably for the burner, no? Or output connector, did I not care about that at all? It wasn't really necessary, I guess. Yeah, I understand, because this is not possible for each. Can I say as that work? Or yeah, but again, there's things in there that they're not chargers. Boy. Oh boy, it's a mess now. this power stuff desperately needs an overhaul. Okay, can I do this? Do it like this and check. Yes. Yes, that's what I wanted to do. This should kind of work, and if it's not, then it doesn't do anything, it just continues. Wait, no. You almost got it right. But it's stop charging, right? How does that even work the other way around? That's so weird. So, device module, because not all of them is power. And we go like this. Yes, there we go. Okay, so this should fix it. Okay, this is kind of works. But on the other hand, this also means that if you're not a charger, you're just not gonna do anything. Oh no, but this is about stopping and starting charging, which is not actually an issue. That's not really what this is about. Right, let's see if some of my bugs have been removed. Device module connector is not set to an instance of an object. Also didn't quite correct, that's true. So when I go to the burner connector, I need to connect the generator module. There we go. I should also connect the power module, I guess. And put the same, it might be true here. There's no generator module there though. But it's also not an issue because let's just connect. Oh, fuck's sake. I need to do it again. See, this is what happens. You don't do it by code, then you forget to do it all together. Oh. There's something wrong with my mouse still, though. Less. If it's power and it's input and it's output, which should only be the case for connector, your output. But the generate module is not set. Oh, let's just remove this. So I did set them. So you don't have to actually do it. It did try to do it by code and it failed, and that's why it was an issue. So I'm just gonna do it by hand, and then I don't even have to do it. Oh, really? No, that doesn't make sense. Well, maybe this fixed all of the those bugs. Apparently it did. So that's true, it should be 0 because there's nothing being burned right now. So let's collect some dust. And then I should... Yes. And the wire, it's still 0 though. So let's start. But the wire did I maybe do that on like... Update available power. We do that on every update. And you should check. Well, I should check my wire then. Also, my wire should now always be turned on. Connected pushers. I just needed to check if that was actually if there was someone in my list of pushers. So the generator is not working, and I considerably simplified it, so that's a good thing. Why is it not being put in the wire? Let's see. There is a power pusher, which is the correct one, but it's not being updated because apparently this connector's output is also not being updated, obviously. So this dot output equals yes. Did I connect to you? Yeah, I did. Now this should work. Now there should be a certain amount of power available in the cable, and that's it. You know, I could keep it really simple and just say whatever power is available in the cable, you use it all, and put no limits on like how much you can use. But this then will also only work for one of them. Wait, suddenly we have a instance. Did I also not set it for you? This should go automatically though. Oh yeah, no, now I'm talking about the connector. This connector should have a reference. This should actually happen on like every update, right? But you're saying that there's nothing connected. Am I trying to catch it to do it automatically? Let's check it again. It should add them to the list, no? Yes, in the wire. Perfect. So we now have power in the wire as well. And things are being simplified, so that's good. So we have power in the generator, which is being transferred to the wire. And that's it. The wire now has a certain amount of available power. Now, so now everything, I think now everything goes back to the wire. This is no longer relevant. I don't need to check 4 pushers. It's not important anymore. But I can now set a certain amount of draw on a connector. And honestly, right now, the easiest thing to do would be is to just give the available power to the one thing. To every one of them. That's the point. Or again, I could just divide it by, and everyone gets a little bit of available power. Wait, isn't that super simple? And that's the total amount. It needs to be negative though, because it's negative draw, this will charge it. The value here is super small though, like the 0.015. That's because in the burner, like the generator, this is still a very, very tiny value. I think I still have to, well, I think if I do times 0.05, it's just a lot. That will be 50. That will charge insanely fast. So we're gonna still say 3600 though. But power generated 50 kilowatts or whatever. What's your problem? Where do I? Oh. Why is it set over there? This is so stupid. Oh, yeah. Okay, because it needs to be set to 0. Yeah. Generated power generated. And now just need to think about the value of this. So now it's going to be insane. It's going to charge so much. Oh, okay. That's a good thing. We could clamp this. If we, right, that's cool. So if we go to the conduit, we can say yes, but it needs to be clamped. Available power, used power. It's already, you can't have less than that divided by 0. I was gonna say I need to clamp it to whatever's available, but it is at most, it's the amount of available power. So that's actually already taken care of. And if this thing is off, it will be 0 divided by whatever, it's still 0. Right, for some reason everything kind of settled into something more or less simple, to the extent that I'm already thinking, could it already be working? Except for the fact that well, we should test it. I just think that the charging rate is now super high. It's 50 kilowatts. So the charging should be super fast. Yes, this works, and it should not be charging right now because the power thingy is not doing anything. So let's empty a little bit. Can you imagine if this is going to work? Gonna give you some power. There's now 50 kilowatts. It's not working, but at least there's 50 kilowatts in the wires. Is it still being burned? Let's check. Yes, so that maintains. We should actually check that it goes back to 0 if this is emptied. The functional power draw on the power puller is not being added right now. Is the wire turned on? That's a good question. It is turned on, which is actually a bit silly. The first thing I want to check is if it drops back to 0 once the once this stops burning, basically. This is no longer relevant, so I don't have a battery in my oven. Kind of makes sense. It's just that as long as it's burning, it will give you. Oh, sorry, I didn't check. It's not being updated to 0 though. Why? Because oh, but this code doesn't make sense at all. Yeah, you can't return, you still need to set it. Yeah, there's something wrong here, definitely. Like some parts of the code are not being updated because you just have these returns here, but in theory, like I do have to put this like everywhere, both these places. But this is duplicated code, so I'm not a big fan of it, but at least it should work. Okay, so that's one thing that should be fixed right now. Let's just check it. Back and forth. So ideally I can just quickly give a small amount of fuel and let it update back to 0. So it is 0, still 0, a little bit of fuel. Yep, stop burning. Got 50 kilowatts in the generator. We got 50 kilowatts in the wires as well. And it should go to 0 once it stops fueling. Come on. Yes, back to 0. Great, so fix that. Now, why is there no actual charging of this thing? So that's the next thing. Let's close all of them because I have too many files open. I don't like it. Let's go back to the wire itself. Let's just put a debug here. Oh. Adding power to, right, in a certain amount. Maybe we should calculate it. Okay, let's do it. Power charge. Volt. you debug this, please? Yeah, that's fine. The power puller. Oh, I also want to know who the power puller is. Can you just show me that? It's turned on. Is actually. I'm gonna remove this because this doesn't make sense anymore. This was mainly to test before if the wire actually worked before and after. But I don't need any of that. Can you show me adding? Yes, that's exactly what I want to know. Just to see if this at least happens. And I should get installed on device. But you're not adding that to a device though, right? You're adding that to a connector module. Yes. So I just want the name. On device. Yeah. I want everything. I want to make sure it's being added to the connector. And as long as that connector is then, it's gonna have a negative power draw, so it's basically should charge the thing. And then everything's kind of working and in a way that I want it to work. It's not ideal, it's not perfect, but actually it's better than what I expect to be able to do. Let's go back and forth one more time. Oh, we can actually see. Adding charge power 0. So that's interesting. Oh no, that's normal because the wire wasn't. That's normal. It was 0 because there was no power on the wire because the burner wasn't working. Right. And it is correct though. It's the device connector on the device. Adding minus 54. Oh, but the device charger. The question now is, did I screw up the whole charging thing by allowing connectors to be chargers? That's kind of the question. But in any case, I can probably check that, right? Can I check functional power draws? I think it's a dictionary, so I don't think I can check it. Right? Let's go to that. Add functional, it's a dictionary. Update power status. No, that's not what I want. I think I need to go to the actual power one. Show me all of the chargers. Wait, I can check that though. I can see that. So that connector, if I go to the charger's power, there is one element here, which is the connector. It's at least in the list of charging devices, so that's good. That's a good thing. Called, right? Where is this being called? It's not being called anywhere. Why is this not being called anywhere? Update charge? Update, no, it's being called here, so that's fine. Update charge. Did I put it on infinite power? That would be stupid, but I don't think I did. No, it's fine. Updating charge. Updating power. Let's check because none of these things are being called. As far as I can see. That's kind of strange. We're almost there, so that's good. Hope to be finish this before the end of 2 hours, and then we actually have the wire finished. That would be nice. Because then we have a connection. Finally. That was difficult. Okay, so. Yeah, sure. Adding. Zero, which is normal. That's fine. Because its power draw is 0. Right? Let's see. Sometimes I really have the feeling that doing no changes, just restarting the game, sometimes fixes things. But that's just probably just all in your head. Come on, give me some dust. I should just put some dust in there just so I can test it. Although it's nice to kind of see it. Right, pause. Adding charge power to connected device. Updating total power charge. That's it. Yes, here. Updating total power charge is being called. But then adding power draw. It's not being called. That's so strange. And there's definitely one in there. Yeah. Fine. Oh, adding power draw to total power charge. No, it is being called. And it says even minus 54. Power charge. Oh. But I do plus, so power charge minus. I think I don't have to. That's a bit tricky though. Because that also means that if the connector starts using power, it will actually, that number will be added to the charge. Because how is the charge then actually? But then it should have like dropped super fast, so that's not necessarily the issue. So can I debug here and give me the total charge, and then where does this get called? There. Alright, I want to see both of those values. Power draw per frame, power charge per frame, and then current charge. Yeah, sure. That's what I want to see. Go back and forth. So sometimes you need to go back and forth between your IDE and when it's still in play mode, because otherwise it doesn't update the scripts. Right, let's press play. So I think at some point here it will work from a practical point of view, but there's going to be mistakes because the connector is now behaving as if it right. Let's press pause. power draw and power charge per frame are equal. Is that possible? No, it should be like literally 50. Why is the power draw 0.00 anyway? It should be 0. No? Okay, let's go. 50 divided by... It's still only 0.013, which should still be more than whatever's written here. So there's a mistake in there. Total power draw, total power charge. Total power charge is showing me that. It says minus 54. Can you also show me update power draw? Oh my god. See, this is the problem, obviously. Yeah, because my connector is also a power drawer and a power charger right now, and it just nullifies itself. That's the problem. Because I'm saying to the connector, hey, let's put your draw into negative because then it's going to be charging. Which, okay, actually what it means is I should not be adding the connector as a charging device, and then it will work. That's all I need to do. Which happens somewhere. This is correct, but the connector should not be a charger, and then it will work. Even though it works in a strange way. Where does this happen? I think it happens then in the power module itself. Here. I should not... Oh, sorry, no. But it is something like this. Somewhere, somehow, I'm adding... The connector should just never become part of the... Probably somewhere here, no? Like at the start, that would make most sense. Okay, I just need to find any... Here. All the references to this. What? Why can't you find? at some point in my code, I'm adding the connector as a power charging device. Can't seem to find where. Pushes is fine normally, I think. Here, this one. It's this thing that I'm adding it somewhere at some point. Here. Initialize module. Yes. This should not be done. There's no point in doing that because of the way I'm doing it right now. Great. And I'm kind of, it's wrong in the sense that now, like, I'm doing it via negative power draw, which is not ideal, but it should work. The downside is that, actually, right? Aha, you see? I'm not 100% sure if it's actually working, because I need to wait until it's empty again, because I can't charge. I mean, I can charge, but this is charging super fast because it's like 50 kilowatts. So I need to wait until this one stops burning. It stopped burning. If I charge now, there you go. But if I put it in there, come on. Yes, did you see it charge? No, you didn't, because they're too far apart. I'll keep my mouse here. Oh, but then I can't move. Okay, but it's working, so that's cool. So I need to move some stuff around to make it a little bit clearer. I'm gonna move this closer, so that it's all in one screen. Finally. And I don't think it's actually the worst, because I think it's much simpler this way. Not to say that I do want to change things. So let me first charge away some stuff. Come on, you need to charge me. Why are you not charging me? I think my zones are a bit too big. Where is the zone for charging? Yeah, so my charging zone is a bit too big for this one. It's difficult for me to just not be in that zone. So let's empty it out. I need to like move out of there fast. All right, okay. So now, there you go. Haha. Ooh. Oh my god. And now this is like, I can charge, like, I have to move out of this charging zone. That's why it doesn't work. So that's why now, right now, if it stops charging, you need to move out and back in of the charging zone to restart it. And again, I prefer just to have a key there and not have it automatically, but then I need to do all those key things, and I want to do that in one package, because I want to have some generic thing like action is F, and then wherever you're standing, F will be either transferring resources or whatever the action is available there. So that's why I want to deal with it later. But look at this. Like, I can charge. We can dust. Oh, need to charge. Oh, and now be careful because my charge is about to be empty. And I need to drop off some resources. It's starting to burn. My charger is recharging. And as long as this is burning, yeah, and now we got the kind of, what's the time here? I'm gonna finish up here because that's just details. Like I removed basically the battery part of the oven, which is, I think it makes sense, but I do want to maybe, I could just remove this, or I could have it like say, okay, if this is now generating a certain amount, and then if you put in a different thing than dust, it could get you a little bit higher because it has higher burning efficiency or whatever, or higher caloric value. Right, so again, charging, it will now no longer charge. Oh, it will charge because I just dropped in some fuel. So that's working. That's nice. I like it. Good. Whew. That was a tough one. Let's get rid of my debugs. And also, like, this is, the loop is complete because as you can see, I can keep going, right? Well, I can't because the vent stops at some point. The vent is not continuously pushing dust at the moment, but there's a loop here. Like, dust is being spawned, I can collect it, I can burn it up. The burning generates energy, which is transferred through a wire to my charging station to recharge the charging station, and the charging station is where I as a robot can recharge myself. And we have like a game loop, as in like, and currently the goal would be make sure all the dust disappear. So there's a few things that from here on out that I can start working on. I can start working on like implementing some UI, as in like starting the game, there's like 100 dust particles being spread out, I need to just clean them all, and that's like the goal of the, and that will be still a very arcadey style of game, but again, that's where we can get started from. And then if you complete all of the, if you collect all of the dust, you win the game. If you run out of power in any of your controlling devices, that basically means that you lost the game. So I can start implementing those kinds of things, which I haven't done before. I think there are a lot of things that I will need to get some help from tutorials or ChatGPT, and also then building the level. Well, there's not much level building here yet, in the sense that, I mean, all you can do is just collecting the dust, there's no jumping or whatever. Although the idea would be here, like there's like multiple rooms, and if you want to clean all the dust, that means you need to clean the dust in the next room, but maybe the door is closed, so you will need to try to get connection to the door and to open it. So you need to find like a Wi-Fi connection, hack your way into the door, open the door, and go to the next room and clean the dust as well. And then, but then you have an issue because now you're like far away from your charging point, and you need to make sure that you can get back and forth in time. Maybe you need to connect to multiple Roombas and have them, like the charging should be much slower. So a Roomba recharging should take like, I don't know, like a minute. So meaning like take control of another Roomba in the meantime while the other one is charging. Start to do some world building as well, maybe even introduce some audio, I don't know, maybe that's time to, so I think now that the game loop is complete, there's a lot of stuff that I can work on that I didn't want to work on before because I wanted to finish a certain thing, which is now kind of the case. And also UI, maybe building wires, adding some new devices like a robot or something that is capable of laying wires a bit further or moving the charger, so I can go further into the next room and start exploring the world, having all the different types of resources. Like one idea is like you can find some resource and put it in the printer. In the beginning I would just say let's just put dust in the printer, and it magically converts it into some kind of printable material, so you can print parts and you can make that's kind of more story wise as well. Like the robot is like, well, I want to clean all the dust, like, but I'm quite constrained as a little Roomba. Maybe it flies a Roomba that can fly because there's dust in the air. All these kinds of things. I'm really starting to ramble right now, but I'm a little bit excited because I got this far. I'm gonna count the hours that it took me from nothing to this and see if I can make a small like summarizing video and put that up as well, because I also know that not many people want to watch these very long form streams, but maybe showing up some of my progress in a short video would help make people a little more interested. Alright, let's finish up. Let's remove all the debugs. I think it's good practice to do that. You might also want to comment them out, because if you want to reuse them, but if you see with Copilot, it's so easy to add debugs. There's not a lot of typing necessary. So that's why I just always remove them, to make it also easier for debugging other things, because if your console is full of debugs from previously, then it just takes a long time to search. I must say I do like the debugging here. You can click it, you can search your debugs, so that's kind of all cool stuff. Warnings are fine, because I do still have, I still want to find out when there's an issue here. Let me save the scene as well. So let's clear this, save the scene, test it one more time, and then I'll commit. And that would be the end of today's episode. I'm happy. It's really cool to see the progress. And again, like, you could say the artwork is totally not a priority, and I would say it's true if it takes a long time, but using these generative AI tools, I can get some decent looking artwork. I even think some of it looks really cool. You can get that going, and it makes, at least to me, it makes development a lot more fun. I was thinking, oh, why isn't that going down? Well, I'm still generating power, so this is still on infinite power. Oh, what did it just do? I just wanted to test it, but anyway, I'm sure it works. So let's go save the scene. Let's go to my changes. This should find all of the changes, stage them. What was my last commit actually? Let's check. Power generation. All right, so this thing is a whole new feature. It's the wires. I will still say this is in the scope of power. Oh. Add wires transferring power from device to device. And I was even thinking of making the charging, the wireless charging where my robot charges, to maybe just implement it in the same way as wires, but then wireless, but still kind of the same class being used. Like if you're there, a little tiny wire pops up and connects you to because actually wireless charging here is not necessarily already a thing. So maybe if you come in here, a small wire pops up, like connects your input. That actually completely makes sense, by the way. That you basically connect small wire here, but just automatically. You don't have to actually build it. It just pops up when you go into the recharge zone, and then it uses the same code to do that recharging. Anyways, so do I have my commit ready? Add wires transferring power from device to device. That's what happened. So let's commit and sync. And we got a I wouldn't say we have a game, but it's like a thing that works start to finish. You could play this. So yeah, I'm happy. I'm also tired. Yeah, cool. I'm happy. I'm making progress, so that's the most important part. So thanks for watching, and see you in the next episode, where the next episode will be a lot of refactoring. So there's two things I want to do. It's just general refactoring and optimization, and maybe work on some schemes of all the things that are currently like connected in terms of power, and how I can simplify things, because I have a lot of different ways of doing things right now, and it gave me quite a bit of trouble to implement this. So I also want to work on that. So the next episode might be very boring for a lot of people, because it will just be refactoring, but it's maybe also interesting to see how I will do that. Not that I actually know very well how to do that, but I will also be using ChatGPT just to ask like what is a good way to make this more optimized for to run the game, and also how it's just easier to make or extend the code later on. So that's what will be in the next episode. Before I go, let's tick off a box here. Power distribution, check. We have our first full game loop. Yes, we do. I think I first want to refactor and optimize before I add the keys, because this might the fact that a lot of the code might change might be influenced by that. So refactor, optimize, and then let's maybe add some of the things that I told about, UI, the game manager, like how to set up, how to start a game, like press play, game over, game manager, start, game over, etc. Have like some UI, and I also talked about some level design, maybe some audio, like just some sound effects, which I just want to check out if I can find some AI tools to do that. That would be nice. I already find a really good tool to do voice, but of course that's not the same as sound effects, so we'll have to check if I can find something like that. Maybe even some music. Yeah, we'll see. All right, great. Thanks for watching. See you in the next episode. Good night.